This video is on the properties of exponents, and it begins our unit on exponential functions. This learning target is learning target 1. I can apply the properties of exponents. Let's just review real quickly what is an exponent. An exponent is another way to write multiplication. Exponents are written up high and small. The 4 in this case is the exponent. We also may call it a power, and we use the phrasing to the power of as the way that we say our exponents. The larger number, in this case the x, is called the base. We're going to be using power and base, exponent and base, and these vocab words often throughout the next couple of units. So if we had a 2 to the third power x squared and y to the fourth power, we can expand this out into the multiplication that makes it. 2 times 2 times 2 is 2 to the third power, times x is x squared, or x to the second power, times y, 4 y's multiplied. Written out like this is called expanded form. Pushing them together with their exponents would be called their exponential form. Here's our first property. It's called product property. It states that if the bases are the same and it's multiplication between the two terms, you can add the exponents. So let's do an example. We have a x to the fifth power and we have a y to the second power. This is getting multiplied to an x to the first power. When there is not a exponent written for you, you assume that it's a 1, and y to the third power. So what we need to do is we need to take the x's and add those exponents, 5 plus 1. And the y's exponents need to be added too, 2 plus 3. So our answer is x to the sixth power and y to the fifth power. Power of a power property states that if a base already has an exponent and that term is being raised to another exponent, we take those two exponents and we multiply them together. Power of a power. So this example of y cubed to the fourth power means that we take the 3 and we multiply it by 4. We get y to the 12th power. Power of a product states that if you have an exponent with multiple pieces to the term that it's being used on, we must use that exponent on all pieces inside of here. So in this problem, we have a 2x y squared. All of this is being raised to the fourth power. The power of 4 gets used in different ways with this 2 and the coefficient of 2. The 2 gets a power of 4. The x, which has an exponent of 1, that exponent of 1 will get multiplied by 4. And the 4 also multiplies to the 2 as well. Notice written this way, each of the terms now has a power of 4 on it. Just in the case of the x's and y's, we do need to multiply it using our power of a power property. So I end up with 2 to the fourth power is 16. X's power is 1 times 4 is 4, and y's power is now 8. Notice that it is not an 8 in the front. A lot of students accidentally do 4 times 2 to the coefficient because they're doing 4 times 2 to the power. So 4 does multiply to the power of 2, making 8, but 4 becomes the exponent for the coefficient 2, which means 2 to the fourth power is 16. Quotient of powers means that if we have the same base on top and bottom, we take their exponents and we subtract them. Let's do this here. I have an x to the third power and an x to a power of 1. I take those and I subtract them. X to the power of 2. I also take the y's powers, 5 and 7, and I subtract those. 7 minus 5 is also 2. Notice what happened here. Since there was more power for x's on top, that subtraction leaves its leftovers of 2 on top of the fraction. There was more power for y in the denominator of this fraction, so therefore 7 minus 5 gives me leftovers that remain on the bottom. Power of a quotient. Similar to power of a product, if you have a fraction and the whole fraction is being raised to a power, we must use that power in both the numerator as well as the denominator. So in this example, the 2 gets raised to the third power, and so does the 3, giving me a new fraction of 8 over 27. Our last two properties are negative exponents and exponents of 0. Negative exponents really badly want to be positive. A negative exponent can become positive if it moves from either the top to the bottom or vice versa from the bottom back up to the top. So let's take a look at the example here. We have an x with a negative 2 exponent. To be a positive 2 exponent, he really badly wants to move down. The y has a negative 5 exponent. To be a positive 5 exponent, he wants to move up. So they are just going to switch their spots to turn their negative exponents into positive exponents. The y will be positive 5 on top, and the x will be positive 2 on bottom. 0 exponents are probably the simplest and easiest exponent property to use. Anything, no matter what it is, when raised to the power of 0 will equal 1. For example, it doesn't matter that I have all these different pieces, the 3, the x squared, and the y. If all of it is being raised to the power of 0, this entire thing just equals 1. Even a 3 to the power of 0 is 1, an x to the power of 0 is 1, anything to the power of 0 is 1. Now let's start to use these properties in combination with each other. I have 4 to the negative third power, a 4 to the 0 power, and a 4 to another negative third power. What do I know? I know that these negative exponents really badly want to move down to the bottom of a fraction. I also know that my 4 to the power of 0 actually equals a 1. So what do I end up with? Well, first off, I end up with the 1 from 4 to the power of 0. 4 to the negative third and 4 to the negative third do want to move down to have positive exponents. Now that I have two terms with the same base, 4 and 4, and it's a multiplication between them, I can add their exponents together. This equals 1 over 4096. Here, I have two terms in parentheses with multiple pieces to those terms inside the parentheses. Also, one set of parentheses is being raised to a higher power. First, we need to take care of this higher power, and then we can multiply them together. This order does matter, because our order of operations says that we have to do our exponents before we do our multiplying. So let's rewrite the first set of parentheses because we haven't used it, and let's write our answer from utilizing the power 3 as an exponent on all the other pieces of this first term. 2 to the power of 3 is 8. X has a power of 1. 1 times 3 is 3. And 4 times 3 is 12. That's power of a power. Now I can go ahead and use our product property and add the exponents from the same bases. We do just have a regular old 2 times 8. That's pretty simple. It's a 16. We have an x to the third power times an x to the third power. That's an x to the 6. 3 plus 3 is 6. X to the second power times y to the second power times y to the 12th power. We add those, and we end up with a y to the 14th power. This is our simplified answer. In this example, we have x's on top and bottom of the fraction. We have a negative exponent. We also have a power to the power here as well. So we're going to first take care of our power to the power, then work on combining pieces on the bottom, and our negative exponents can move to the top. 2 gets raised to the fourth power and becomes a 16. And x is negative 4 gets multiplied by a positive 4 and makes negative 16. Now I can take this negative exponent on the x and move him up. Now on top it says x times x to the positive 16th. On bottom is still the x to the third and the 16. Let's combine these x's on the top. We end up with x to the 17th for a 1 plus 16. And the bottom we just have a 16 with an x to the third. We have same bases on top and bottom of the fraction, x's. This is time for subtraction of exponents. 17 minus 3 is going to give me my final answer. X to the 14th power on top with just a 16 on the bottom. So that covers the learning target on properties of exponents. Remember, you're going to be using these properties in combination with each other. You will see some more complicated examples like this one, as well as the simpler examples you saw in the beginning. If you have questions, make sure you shoot me a text if you can. And if you want to, you can, of course, write down your questions in your notebook and bring them in the class.